Welcome to this tutorial. My name is Ademola Folarin. In this tutorial, we'll be learning about the concept of variation. So by the end of this video, we should be able to understand the concept of variation. We should be able to differentiate between the types of variation, and we should be able to solve problems involving variation. This tutorial is powered by eHorta Virtual Learning. So let's start. Variation is from the word vary. What is variation? Variation describes how one quantity changes in relation to the other. Basically, it tells us the relationship between variables, how one variable affects the other, how changing one variable affects the other. So that is what variation tells us. It shows the relationship between two or more variables in relation with one another. There are four types of variation. They are direct variation, inverse variation, joint variation, and partial variation. Let's take them one by one. For direct variation, this occurs when variable increases or decreases in direct proportion to another variable. If a particular variable increases or decreases in direct proportion to another variable, let's say for example we have variable y, and if this varies directly as variable x, it means as x increases, y will also increase, and as x decreases, y will also decrease for a particular constant value. So mathematically we express it as y equals kx, where k is the constant of proportionality. A very good life example of this is the earnings and hours worked. If a company says we pay 5 naira per hour, that means the amount a worker will earn is proportional to the number of hours the worker works. If the worker works at a very high number of hours, the amount the worker will earn will also increase. So that is direct variation. For inverse variation, this variation occurs when one variable increases while the other decreases, in such a way that their product is constant. What are we saying here? Let's say we have a particular variable y. If it varies inversely as x, which we can express as saying y is equals to k, which is a constant of variation, divided by x. It means as x increases, as the value of x increases, the value of y will be decreasing. And as the value of x decreases, the value of y will be increasing. A very good life application of this is the speed and travel time. For a particular fixed distance, if a car is traveling that distance, if the car speed up, the time taken for the car to cover the distance will reduce. But if the car walks slowly, the time taken for such car to cover that fixed distance will increase. So as the car speed up, the time taken reduces. Now for the third one, which is the joint variation. This occurs when a variable varies directly with the product of two or more variables. That is, there is connection between one variable and two or more other variables. Say for example, we say y varies directly or varies jointly with x and z. y varies jointly with x and z, which we can mathematically express as y equals the constant of variation x, z. A very good example of this is the volume of a rectangular prism. The volume of a rectangular prism varies jointly with the length and the width. That is, the volume of a rectangular prism depends on the length of the prism and the width of the prism. That is joint variation. It involves more than two variables. And the last part is what we call partial variation. Partial variation occurs when a variable is related to another but not completely proportional. When a variable is related to another but is not completely proportional, here it combines both direct variation and a constant term. Let's say, for example, if we say y varies partially with x, y varies partially with x. That statement can be expressed as y varies partially with x will be equals to the constant of variation k as x. Since it varies partially with x, so it varies with x with another constant. That's a partial constant there. So in this situation, k and c are constants. That's partial variation. A very good example of this is, let's say, when you go to rent a sound engine, and if they say, okay, for an hour, we rent this sound engine at the rate of 100,000 naira. However, based on how you increase the intensity of it, we may also charge a particular amount. Such is partial variation because there is a fixed amount and there is also a particular amount that you deposit for it. Such is partial variation. Now we understand these four types of variation. Let's take live example of it and solve one by one. We have this example. Given that y varies directly as x and inversely as the square of z, and we are given those initial conditions, how do we solve this type of problem? In this situation, we have, given that y varies, we have to first interpret this. Given that y varies directly as x, so you recall that varies directly means y varies directly as x. This same y also varies inversely as square of z. Y varies inversely as the square of z. So if we then combine this, we can say y varies directly as x over z square, which mathematically it becomes y is equals to constant of proportionality, that's k, x over z square. So now we've been able to interpret this, given the condition that if y is equals to 4, when x is equals to 3 and z is equals to 1, this first condition will help us to really determine the relationship between y, x, and z. By so doing, we will get a value for k. So let's go on with that. to do this, we begin to plug in the value. When y is equals to 4, that will be 4 equals k, we don't know the value of k yet, multiply by x is 3, divided by the square of z, that's 1 square, which becomes 4 is equals to k multiplied by 3, that's 3k. 1 raised to power 2 is 1, so it's going to be 3k divided by 1, which is the same thing as 3k. From here we can say 4 over 3 equals to k. Now that we know that, we can then say the relationship will be y is equals to 4 over 3x all divided by z, which we can say y is equals to 4x divided by 3z, right? That's the relationship. Now we have a further question that says we should find the value of y when x is equals to 3 and z is equals to 2. So to do that, y will be equals to, so what will be the value? That will be 4 multiplied by x is 3 divided by 3 multiplied by z is 2. Then we have y is equals to 12 over 6, which y is equals to 2. So this question is a WAEC question, May, June, year 2010. This is what the question is expecting us to do. Alright, let's take another question to better broaden our understanding of this concept. This question says, the cost of making a dress varies, partly constant and partly varies with the amount of time it takes. So this is a question under partial variation. It's a question under partial variation. So let's look at how we can easily interpret this. The cost of making a dress is partly constant and partly varies with the amount of time. Let C represent the cost and T represents time. So we can say C partly varies, is partly constant. Let's say C is partly constant. Let me say the constant here, we use A. Then it partly varies with a particular amount of time. Let's call that one KT, where A and K are constants. So we've been able to do this. The question now says, if the dress take 3 hours, that is when T is equals to 3 hours, its cost C is equals to 2,700. So if we put in this, it becomes 2,700 equals A plus KT, that's 3 times K, that's 3K. Let's take that as equation 1. Then we move on to interpret again. If it takes 5 hours to make the dress, it costs this. So when C is 5, when C is 3,100, T is 5 hours. So we say 3,100 equals A plus 5k. That's equation 2. Now that we have this as equation 1 and 2, we can solve this simultaneously. This is very simple. We can say let's subtract equation 1 from equation 2. That is equation 2, equation 1. So if I remove 2,700 from 3,100, what will I get? 400. Good. 400 equals, when you remove this A from this A, you are left with 0. Very good. Now when you remove 3k from 5k, what do we have? We have 2k. So 2k. Hence we can say 400 divided by 2 equals k. Then k will be equals to 200. Now that we know that k is equals to 200, it means the relationship of these two variables, the cost and time, we are getting closer to it. So if k is 200, we can actually now find the value of A. To get the value of A, we substitute the value of k into any of the equation 1 or equation 2. So substituting k, substitute 200 for k in equation 1. I'm picking equation 1 because equation 1 seems to have smaller value that I can easily work around with. So it means I will have 2,700 equals A plus 3k. Here now the k will take the place of 200, will take the place of k. That's 200. So we then have 2,700 equals A plus 600. So from here we have 2,700 minus 600 equals A. That will be 2,100 equals A. Hence, the relationship between C and T, that is the cost and time, will now become C equals the value of A, that's 2,100, plus the value of K is 200 multiplied by T, 200 T. So this is the relationship connecting the cost and time. Remember, that is what we call variation. The relationship connecting two or more variables. Now the question is now saying find the cost if it takes 1.5 hours to make the dress. If it takes 1.5 hours to make the dress, we should find the cost. That is, when T is equals to 1.5 hours, we should find the cost. We don't know the cost. So using this relationship, we will just say the cost equals 2,100 plus 200 multiplied by 1 whole number 1 over 2. So when we do that, we are going to have 2,100 plus 200. This 1 whole number 1 over 2, we can turn it to improper fraction. That will be 2 multiplied by 1, that's 2, plus 1, that's 3 over 2. And then it can become 2100 plus, when we multiply 200 with 3 over 2, we have 100 multiplied by 3. That's 2100 plus 300. So we then add this together, that will be 2400. Therefore, the cost of the dress when it takes 1.5 hours to make is equals to 2400 naira. So we've been able to answer question on variation, taking note of first establishing the relationship between any given variable or the given variables. There are 4 types of variation. We say they are direct variation, which explain that as one variable increases, the other increases. We have inverse variation, which tells us that as one variable increases, the other decreases. And we have joint variation, which tells us that one variable can vary directly as product of 2 or more variables. And we have partial variation that tells us that a particular variable can be partly constant and as well partly varies with another variable. So if you enjoy this, don't forget to subscribe, share this video for more interesting tutorials like this. Thank you.